Fundamentally, at the heart of calibration is this idea of having some points whose three-dimensional location in the world we know, and that we identify them in an image. That is, we can find the correspondence between this point in the image is that point in the world. And then we have to compute some sort of a mapping from a scene to the image. And one thing you can do is you can actually put an object like this in the scene that has a bunch of points on it, and you've measured or you know something about the shape of that object, and you know where all the points are. Another way of doing it is to make use of, it's sort of the same math, but it's typically referred to as resectioning, which I'm pretty sure is a term that came from photogrammetry, which is a science that predates computer vision by about a century, that talked about going between images and three-dimensional world, typically used for mapping, cartography, and stuff like that. So in resectioning, which is what we're going to do here, the basic idea is we're going to have some known points. So on the right here, we have a picture of one of our labs, and one of the times one of my colleagues was using a theodolite. That's the thing that surveyors use in order to measure things out, for property or houses. And we set up the theodolite in the lab, and we established a world coordinate system, and you notice we put down these markers. These are actually sort of printouts of what surveyor marks look like. And what we did was we measured the three-dimensional location in the world with respect to this coordinate system of those points. All right? So what that does is that's going to give us a set of points, x, y, z. And then, of course, given an image like this one, we can find the location of uv in that image. Notice again that I'm using the homogeneous version of the points. Here I'm calling it W, so this is W, U scaled by W, V scaled by W, and that's W. And this was that original equation. So clearly, given enough points in the world in the image, I should be able to recover the calibration matrix, and here's how.